Um, Hello everyone. So here we shall solve some more KCET previous year questions on the chapter Electrostatic, Potential and Capacitance. So in the previous part of this chapter KCET we had solved till the question number 28. Here we shall solve from question number 29. So if you have any doubts regarding any of the steps of the solutions in any question, then please write that in the comments section. And in any of the chapters of physics, if you difficulty, then also mention the name of that chapter in the comment section. Shall give more clarity on it and solve run more KCT previous year questions on that chapter. Um, Also, the homeworks on every chapter will be uploaded in the Sapience Education application. Please install our Sapience Education application. Link has been provided in the description. So here in question number 29, it is told a parallel plate capacitor is charged and then isolated. So one parallel plate capacitor is there. It is given some charge Q minus Q, and then it is isolated. So since it is isolated, its charge will not come out the surrounding. It means that its charge will remain conserved according to the law of conservation of charge. Charge is conserved. That it will charge will remain constant. So it's told then the plate separation D that is increased. When the plate separation is that capacitance C that is equals to epsilon naught A by D. Now if the plate separation is increased, the capacitance will decrease. And we know that Q equals to CV. Now since Q should remain constant, so when C will decrease, then the electrostatic po- po- potential across the capacitor plates will increase. Since capacitance is decreasing, so the potential difference should increase across the capacitor plates. Therefore, charge will remain constant. Charge will remain constant and the potential will increase and the capacitance will decrease. Means that option B is the correct answer. In question number 30, it is told a spherical shell of radius 10 centimeter is carrying charge Q. There is a spherical shell having radius R, which is 10 centimeter. It is carrying some charge Q. There is a spherical shell. Means the inside is hollow. If the electric potential at distances 5 centimeter, 10 centimeter, and 15 centimeter center the spherical shell is V1, V2, and V3 respectively, then we know that when R is greater than or equal to the radius, here R the radius is 10 centimeter, when R is greater than or equal to R, then the potential, the electric potential V is given as KQ by R. KQ by R. Sorry, it will be KQ by R. And when R is less than R, then V is given as the spherical shell, so it will be KQ by R. So it means that V1 will be equal to V2. Since why for V1 R is equal to 5 centimeter, which is less than 10 centimeter, since 10 centimeter is R. So the electric potential for a hollow spherical shell inside, so at any point inside the hollow spherical shell, the electric potential is same as that on the surface. So it means that V2 is the electric potential on the surface, so it will be same as that at any point on the inside. So V1 will be equal to V2, and that is greater than V3. Since V3 will be KQ by 15 centimeter. It will be obviously less than KQ by 10 centimeter. V1 equal to V2 greater than V3. So option D is the correct answer. Then in question number 31, it's told the nature of equipotential surface for a point charge is, for a point charge, the equipotential surface are spheres. Spheres which are centered around the charge. Sphere with charge at the center of the sphere. So option B is the correct answer. Question number 32 is told a particle of mass 1 gram, charge 1 microcoulomb. Okay. A particle is there whose mass is 1 gram and its charge is 1 microcoulomb, is held at rest on a frictionless horizontal surface. A frictionless horizontal surface at a distance 1 meter, at a distance 1 meter from the fixed charge Q2, is 2 millicoulomb. If the particle is released, it will be repelled. The speed of the particle when it is at a distance of 10 meter from the fixed charge. So this Q charge, this is fixed, but this charge is not fixed. It can move. So how much will be the speed of the particle when it is at a distance of 10 meter charge? So here we can say we have to apply the rule. There is loss in potential energy, loss in electrostatic potential energy, that will be equal to gain in the kinetic energy. Gain in kinetic energy. So now, initially it was at rest. Let's say this is Q1, or let's say this is capital Q, we say. This fixed charge, let its symbol be capital Q. So loss in potential energy, that will be initially, suppose it was, so initially R initial was 1 meter and R final is 10 meter. If loss means it is initial minus final, so it is K Q by R initial minus KQ by R final. Since R initial is less than R final, so 1 by R initial will be greater than. Since loss in potential energy, that we have to do initial potential energy minus the final potential energy. Now that is equal to gain in kinetic energy of the particle which was initially held at rest. It will be half mv square. Half mv square. Then therefore this v has been asked, the speed of the particle when it is at a distance of 10 meter from the fixed charge. So k is 9 into 10 power 9 in q, the capital Q, that is 2 millicoulomb. So it's 2 into 10 power minus 3 coulomb. Power KQ 1 by R initial by 1 by 10 is equal to half into M, the mass of this charge. So the potential energy, it should be actually KQQ by R. So Q also we have Q 1 microcoulomb 10 power minus 6 into this. Okay. Therefore, we can say half into M. 1 gram means we can say 10 power minus 3, 10 power minus 3 kg. Since we should use the SI units only. Half M square. Half M into V square. So this will be equal to yeah, power minus 3 kg. That is 18, 18 into 10 power 6, 9 by 10. V square will be equal to into the 36 and 9, 10 power 5, 36, 4 9 are 36, 36, 9 to 10 power 6, 36 into power 5 into 9 divided by 10 power minus V square is 9 into 36, 10 power 8, millicoulomb. Okay. So this will be minus 3 actually, 9 something. So this will be 10 power minus into V square equals to 10 power minus 9, 10 power 9 will cancel. So this is equal to 18 to 9 by 10. So this will be square is equal to 36 into 9 by 10, 10 power minus 3. That square is 6 into 9 into 100. Is that V will be equal to 6, 6 or 36, 10, 80, 80 meter per second. Option D is the correct answer. Then it's told that four metal plates are arranged as shown. Capacitance in between X and Y. A is the area of each plate. D is the distance between plates. plates are arranged as shown. This is metal plate X, this is plate Y. 4 metal plates are arranged as shown, capacitance X and Y. A gives the area of each plate and B is the distance. So now, if this is at potential V1, area of each plate is A. This is at V1, then this one will be also at V1. You have to find the capacitance X and Y. Say this is point X across X and 1. So point is V1. So here the capacitance is C, then these two are connected in series, so the equivalent capacitance C equivalent is C by 2, where C should be equal to epsilon naught A by D. So here actually 3 capacitors are there, it's across, and is across V1 and Y, V1, and another one is across V1. So their equivalent is 2C, C plus C is 2C. Equivalent is not by 2, the equivalent is, this can be written equivalent to, this is C and this is 2C, this is X and Y. They are now connected in series, so therefore C equivalent will be equal to C into 2C by C plus 2C square by 3 by 3C, C by 3. Therefore, the equivalent capacitance C is equal to epsilon naught A by D, so C equivalent will be by 3 epsilon. Means that option C is the correct answer. It's told a system of 2 capacitors of capacitance 2 microfarad, capacitance 2 microfarad, 4 microfarad connected in series. Okay, these two capacitors, these 2 capacitors 4 farad and they are connected in series across a potential difference 6 volt. Because the electric charge and the energy stored in the system are. Now this can be, these 2 capacitors which are in series, they can be equivalently replaced by a single capacitor having capacitance C equivalent, which will be given as 2 into 4 by 2 plus 4 microfarad, which will be equal to 4 to the 8 by 6, so 2 3 6 2 4 8, so 4 by 3 microfarad. This is 4 by 3 microfarad. 6 volt is connected to it, so therefore the total electric charge in the system, electric charge stored in the system, P equal to Q, which is equal to C equivalent into V. P equal to 4 by 5 microfarad into V. V means the potential difference across these two capacitors, which is 6 volt. So 3 to the 6, that is 8 microcoulomb. And then the total energy stored in the system, energy stored will come as half C equivalent into V square. Is half into C equivalent into V square. So that will be half into C equivalent is 4 by 3 into V square, that is 6 square. So 6 into 6. So 2 3 is 6, 4 6 are 24 microjoule. 4 by 3 microfarad. So it will be 4 by 3 into 10 power minus 6 also. So it is 24 microjoules. So it means that option B is the correct answer. 8 microcoulomb is the electric charge stored. The electric charge stored in the capacitor, and half C equivalent V square is the energy stored in the capacitor. Okay. Option B is the correct answer. Then question number 35, it is told two point charges A and B. So the point charge A is having charge Q1, which is 3 nanocoulomb. Charge B is having charge Q2, which is plus 1 nanocoulomb. They are placed in air 5 centimeter apart. So they are placed 5 centimeter apart in air. The work done to move charge Q towards A. Work done to move charge B towards A by 1 centimeter. So it means that here the work done by the external force, that will be equal to the increase in the potential energy of B. Increase in the potential energy of B. So now, therefore, work done by the external force, that will be equal to work done by external force to move charge B to the is moved by 1 centimeter towards A. Then work done by external force will be equal to change in potential energy, which is actually the increase. It is happening increase in the potential energy of the charge B. So that will be equal to K Q1 Q2 by R final minus K Q1 Q2 by R initial. So here we can see that initially initially R initial was 5 centimeters, since they were initially placed 5 centimeter apart in air, and R final, that is 4 centimeter, since why charge B uh, is moved towards A by 1 centimeter. Now therefore work done by the external force, that is equal to K is 9 into 10 power 9 into K, so Q1 is 3 nano coulomb, so it is 3 into 10 power 3 into 10 raised to minus 9 coulomb. So it will be broken by the external force into 10 power 9 into 3 into 10 power minus 9 into 10 power minus 9 into 1 into 10 power minus 9 into R final 1 by 4 centimeters. So 4 into 10 power minus 2 minus 1 by 5 into 10 power minus 2. This should be the work. This will be equal to 3 9s are 27. 27. So 10 power minus 9 and 10 power 9 will cancel. Into 10 power minus 9 into 10 power 2 to 1 by 4 minus 1 over 1 by 4 minus 1 by 5. This will be equal to 27 into 10 power minus 7. So this is the 20 and 5 minus 4. So this will be by 20 2 the 2 yeah 6 2 5 the 10 13.5 by 10 I can do. So it is 1.35 into 10 power minus 7 joule. So this is the required answer. So option B is the correct answer. Then here it is told the minimum value of the effective capacitance that can be obtained by combining three capacitances 1 picofarad, 2 picofarad and 4 picofarad is simply by connecting them in series. So the rule is that the effective capacitance is the least, means effective capacitance is the minimum when all they are connected in series. The effective capacitance is minimum when all the three capacitors are connected in series. So when they are connected in series, therefore 1 by C equivalent is the C effective, you can say. So that will be 1 by 1 picofarad, means 1 by 1 to 10 power minus 12 plus 1 by 2 into 1 by 2 into 10 power minus 12 plus 1 by 4 into 10 power minus 12. Since by 1 picofarad means it is 10 power minus 12 farad. So this will be, so 10 power 12 I can take as commons, then this will be 1 plus 1 by 2 plus 1 by equal to 10 power 12 into, so the LCM is 4, this is 4 plus 2 plus 1, so this is 4 plus 3, that is 7 by 4. So this is 7 by 4 into 10 power 12. For C equivalent, so here the C equivalent will be the required minimum value of the effective capacitance. The minimum value of the effective, this is the minimum value of the effective capacitance C equivalent, that will be 4 by 7 into 10 power minus 12 farad, which is also you can write 4 by 7 picofarad. So option B is the correct answer. Then here it is told a mass of 1 kg carrying a charge. So one mass is there, its mass is m, which is equal to 1 kg, and it is also carrying a charge q, which is 2 coulomb, and then it is accelerated through a po- potential. It is accelerated through a potential of 1 volt. The velocity acquired by it is, so we know that the gain, here we have to apply the gain in kinetic energy. So the gain in kinetic energy, that will be equal to the work done by the electric field, work done by the external electric field. Therefore here work done by the external electric field, that will be equal to, that is equal to charge q into v, that will be equal to half mv square. So therefore we can say that v, so v will be equal to 2 qv by m, square root of that. So this will be square root of 2 into q, charge is 2 coulomb, and the potential is 1 volt and mass is 1 kg. D is equal to 2 meter per second. Option B is the correct answer. Then in question number 38, it is told, for the arrangement of capacitors as shown in the circuit, the effective capacitance in between the points A and B is, capacitance of each capacitor is 4 microfarad. For the arrangement of capacitors as shown in the capacitance points A and B. Okay. So this can be written, can be equivalently drawn like this also. So all are 4 microfarad. So let's say their capacitances are C only, where C is equal to 4 microfarad. So across the points A and B, we have to find the effective capacitance. Now here, so actually here it is a Wheatstone bridge actually, since why these, the ratio of these two capacitors equal to these two capacitors. That means that no current will flow through this capacitor. So therefore equivalently we can say it is like this. Equivalently it is like this, A and B. So this is C. So these two capacitors are in series. So their equivalent is C by 2 for each. So this capacitor is C by 2. This one is also C by 2. Then A across A and B, these two capacitors are connected in parallel. These two capacitors are connected in parallel. So their equivalent capacitance is C by 2 plus C by 2, which is C. So therefore the equivalent capacitance is C, is equal to 4 microfarad only. So it means that option A is the correct answer. Then in question number 39 is told, find the work done to move a charge on an equipotential surface. So in an equipotential surface, if we have an equipotential surface, then at every point the electric potential will be the same. So in so across any so at any point in the equipotential surface, the electric potential at every point is the same. So there is no electric field across any so there is no electric field in on any equipotential surface. Therefore, there is no work done to move a charge on the equipotential surface. So we should tell that since V is same, V is constant, means the electric potential, V means the electric potential is constant in an equipotential surface. Equipotential surface. So there is no electric field on the equipotential surface. There is no electric field across, there is no electric field on any potential surface. There is no electric field on any equipotential surface. So the work done to move a charge on the equipotential surface is 0. The work done to move a charge on the equipotential surface is 0, since there is no electric field. So the work done to move a charge on the equipotential surface. So option D is the correct answer. Then question number 40, it is told two capacitors of 3 microfarad and 6 microfarad are connected in series. C1, which is 3 microfarad, C2, which is 6 microfarad. They are connected in series, and a potential difference of 900 volt is applied across this combination. Potential difference of 900 volt is applied across this combination. Then they are disconnected and reconnected in parallel. Then the potential difference across the combination is. So when they are connected, then the C equivalent will be equal to C1 C2 by C1 plus C2, since they are connected in series. So this will be 3 into 6 by 3 plus 6 microfarad. So this will be 18 by 9, which is 2 microfarad. So now therefore the electric charge that will be formed on each of them, Q1 will be equal to Q2, that will be equal to C equivalent, the potential difference, 900 volt. This will be equal to 2 microfarad, so it is 2 into 10 power minus 6 into 900. This will be, this is 1.8 into 10 power minus 3 coulomb. Then there, so each capacitor will have the same charge since they are connected in series. Now they are connected in parallel. Now they are connected in parallel. Then what will be the potential difference across the combination? So when they are connected, this is also having charge q, this is also having charge q, where q is 1.8 10 power minus 3 coulomb. So the potential difference across them, across the combination, that will be equal to, suppose that is V. So V will be equal to, this is C1, this is C2. Across this, the potential is V1. Across this, the potential is V2. Then it will be C, is that charge redistribution will take place so that the potential difference across them will be the same. So this will be Q1 Q plus Q divided by V1 plus V2. Sorry, C1 plus C2. Simply it will be C1 V1 plus C2 V2 by C1 plus C2. This will be C1 V1, that is same as Q1 plus Q2. So Q1 plus Q2 is same as Q only by C1 plus C2. Therefore, the potential difference across the combination of these two capacitors, that will be Q1 and plus Q2, that is 2 into this, so that is 3.6 into 10 power minus 3 divided by C1 plus C2, that is 9 into 10 power minus 6. This will be 4 9 36. So this is 0.4 into 10 power 3 volt, which is 400 volt. So option D is the correct answer. Then here it is told two metal plates are separated by a distance of 2 centimeter. The potentials of the plates are minus 10 volt and plus 30 volt. The electric field between the plates are so we know that electric field is delta V by delta x. Delta V by delta x means it is the potential difference by the distance of separation in between the plates. That will be 30 minus of minus 10 divided by 2 centimeters. So that is 2 into 10 power minus 2. So this much volt per meter. That will be 40 by 2 into 10 raised to 2. So it will be 2000 volt per meter. So option A is the correct answer. Then it is told, question number 42, the equivalent capacitance between A and B is. Equivalent capacitance between A and B is. So we can draw it like this. We can equivalently draw this circuit like this also, that across A and B, so we have here we have one capacitor, another capacitor, then B, and here we have said okay, two are in series like this. So it is actually it is like this. So this is 50 picofarad, this is 100 picofarad, this is also 100 picofarad. 200 picofarad capacitors are in series, which are n parallel with 50 picofarad. This is 150 picofarad. So their equivalent is 50 picofarad. So, and this will be 50 picofarad and this will be also 50 picofarad. This is A and this is also 50 picofarad. So 50 and 50 are connected in parallel. That is why their equivalent is 100 picofarad. So then 100 and 50 are in series. So 100 picofarad, and so this is equivalent to this. This is also equivalent to this. 100 picofarad is connected with picofarad. This is B. So 100 picofarad and 50 picofarad, that is in series. So their equivalent will be 100 into 50 by 100 plus 50, which is 150. So 5 3 is 15. 100 by 3, that is, so 100 by 3 picofarad. So option D is the correct answer. Then in question number 43, it is told a capacitor of capacitance C charged by an amount Q is connected in parallel with an uncharged capacitor of capacitance 2C. A capacitor of capacitance C charged by an amount Q is connected in parallel with an uncharged capacitor of capacitance 2C. Charge is 0. The final charges on the capacitor are, here charge redistribution will take place so that the potential difference across them should be the same. So V will be equal to Q1 plus Q by C1 plus C2. So that will be equal to Q plus Q by C plus 2C. V will be equal to Q by Q is small q is 0 and this is 3C, 2 by 3C. So therefore the final charges on the capacitor. So for the first capacitor, the charge is suppose Q1, capacitance is C, and here for the second one the capacitance is 2C and its charge is suppose Q2. Then Q1 will be equal to C into V, that is C into Q by 3C, that is Q by 3, and Q2 will be equal to 2C into V, that is 2C into Q by 3, Q by 3C, so that is 2Q by 3. So so Q by 3 and 2Q by 3. So option A is the correct answer. Question number 44, it is told a particle of mass m, there is a particle of mass m and its charge is q. It is placed at rest u equal to 0 in an uniform electric field. Electric field is there and then it is released. So it will have some acceleration. Acceleration will be there. The kinetic energy attained by the particle after moving a distance y. The kinetic energy that it will attain, kinetic energy how much it will attain after moving a distance y. Now therefore we can tell that the gain in kinetic energy that will be equal to the work done by the external electric field. External electric field. The work done by the external field will be equal to QE is the force into displacement, which is y, QEY, that is equal to gain in kinetic energy, which is kinetic energy final minus kinetic energy initial. Since initially it was at rest, so initially kinetic energy was 0. So the final kinetic energy attained will be QEY. Option A is the correct answer. Then in question number 45, it is told the figure gives the electric potential V as a function of uh, as a function of distance through 4 regions on the x-axis. Which of the following is true for the magnitude of the electric field E in these regions? So we know that the electric field is minus dV by dx. It means that it is negative of the slope of V versus X graph. The electric field at any point we have to find by finding the slope of V versus X graph. So electric field at the region A, electric field in the region A will become 0 since the slope is 0 here. In this region means the graph is somewhat like this. So in this region the slope is 0 since why this is a straight line which is parallel to the x-axis. Now in this region the slope is having it is a positive slope. B, it is having a positive slope since why it makes an acute angle with the positive x-axis. So electric field at in the region B will be negative. So the electric field in the region B, we can say it is negative of the slope, means it is minus of the slope. How to find? This is 4, this is 2, 4 volt, this is 2 volt, and this point, this is 2 meter, this is 1 meter, this is 4 meter, this is 5 meter. Okay, so this will be y2 minus y1 by x2 minus x1. So this is 4 minus 2 by 2 minus 1, this much volt per meter. So it is electric field in the region B is minus 2 volt per meter, minus 2 volt per meter. Electric field in the region A is 0. Electric field in the region C, that will be again 0 also, since here also in this region C the uh, it it is a straight line which is parallel to the x-axis, so its slope is 0. And here in this region the slope is negative since it makes an obtuse angle with the x-axis. So the electric field in the region D, that will be equal to, here it is 4, this is 0 volt, so it is negative of the slope, which is slope is y2 minus y1, y2 that is 0, 0 minus y1 4 by 2 minus x1, so that is minus of minus 4, that is 4 volt per meter. So therefore we can see that the electric field in the region D is the highest, and then it is greater than the electric field in the region B, and electric field in the region A, that is equal to the electric field in the region C. So it means that option D is the correct answer. Then in question number 46 it is told a system of two charges separated by a certain distance apart stores electrical potential energy. Electrical potential energy it will store if the distance in between them is increased, the potential energy of the system. So the initially the potential energy of the system, that is given as k q1 q2 by r is r. Two charges if the distance between them is increased. So if r is increased, then the potential energy will decrease. The potential energy will decrease if q1 into q2 is greater than 0. It means that if q1 and q2 are having the same sign, but if q1 and into q2 is less than 0, it means that if both the charges are having opposite sign, then if r in, then it means that the potential energy of the system is negative. Now if r is increased, it means that their separation is increased, the distance between them is increased, then the potential energy will also increase. So the correct answer is option A. So it may increase or it may decrease. So it means that if the rule is that if both charges both charges are of same kind. Both charges are of same kind. It means either both are positive or both are negative. Both are negative. Then there then the potential energy of the system will decrease, sorry. But if they are of the opposite sign, it means they are of the opposite kind. They are of the opposite kind. It means that one is positive charge and one is negative charge. Then when the separation is increased, then the potential energy of the system will also increase. So it means that it may increase or decrease. Then in question number 47, it is told figure shows 3 points A, B, and C in a region of uniform electric field. The line AB, so this is the region of the electric field. Now here, this is point A, this is point B, and this is point C here. The line AB is perpendicular and BC is parallel to the field lines. Then which of the following holds good? VA, VB, and VC represent the electric potential at the points A, B, and C. So now we know that the plane which is perpendicular to the field lines, the plane which is perpendicular to the electric field lines is an equipotential surface. Is an equipotential surface. And you know that the electric potential will decrease in the direction of the electric field, and the electric potential decreases in the direction of the electric field. Electric potential decreases in the direction of the electric field. So the electric potential at the point A should be equal to the electric potential at the point B, and at point C it will be less. It means that VA equal to VB, which is greater than VC. It means that the electric potential at the point C will be less than the electric potential at the point B. In the direction of the electric field, V will decrease. It means that VA is equal to VB, which is greater than VC. It means that option D is the correct answer. Then in question number 48, it is told a dipole of dipole moment P and moment of inertia I. So one dipole is there, which is minus Q plus Q, and it is having dipole moment P and it is having moment of inertia I. It is in an uniform electric field E. It is in an uniform electric field E. If it is displaced slightly from its stable equilibrium position, the period of oscillation of the dipole is. So this is theta. So then we can say that the period of oscillation. So here we can say that the torque on an electric dipole, that is given as P cross E, which is PE sine theta. So torque will be equal to PE sine theta. And if the angle theta is very small, then we can say that the torque will be equal to PE theta. So PE theta, that is equal to minus I alpha. Minus I alpha means it is d square theta by dt square. So it means that d square theta by dt square, that is equal to PE by I minus PE by I into theta. Now, so therefore, this is the square of the angular frequency of oscillation. So omega is root over PE by I. Now omega is 2 pi by t, where t is the time period of oscillation of the dipole. So therefore t will be equal to, this is I, so therefore t will be equal to 2 pi to root over I by PE. So it means that option D is the correct answer. Then in question number 49, it is told the difference between equivalent capacitances of two identical capacitors connected in parallel to that in series. So two identical capacitors are there, C and C. So they are connected in parallel also, and they are connected in series also. And the differences in between their equivalent capacitances here, let's say here the equivalent capacitance is C1, and in case of series connection, their equivalent capacitance is C2. Then C1 minus C2, that is given as 6 microfarad. Then the value of capacitance of each capacitor is, okay, so now therefore C1 will be obviously 2C, and C2, since they are connected in parallel, therefore we have to add. C1 will be equal to 2C, and C2 will be equal to C by 2, since they are connected in series. So therefore is told 2C minus C by 2, that is 6 microfarad. So therefore it is 2 to the 4, so 3C by 2, that is equal to 6 microfarad. So it means that C will be equal to 2 by 3 into 6 microfarads, that is 3 to the 6, 4 microfarad. So each capacitor is having capacitance 4 microfarad. So option A is the correct answer. So then we shall solve the last question of this video. So it is told that a hot filament liberates an electron with zero initial velocity. A hot filament is there, a hot filament, it liberates an electron with zero initial velocity. Its initial velocity is 0. The anode potential is it is 1200 volt. So we know that the electron will go from the cathode, which is the hot filament. So the cathode has hot filament, and from here the electron will go towards the anode plate, which is having a positive potential of 1200 volt. The speed of the electron when it strikes the anode. So therefore we know that the gain in kinetic energy, that will be equal to the loss in electrostatic potential energy. So this will the gain in kinetic energy, so that will be half mv square minus half mu square, that is equal to the loss in potential energy, which is equal to E into V, where E is the charge on the electron. So this speed of the electron when it strikes. Okay, so U is 0, it is told, so initial kinetic energy is 0. Therefore V square will be equal to 2 ev by m. So V will be equal to root over 2 ev by m. Therefore the speed of the electron when it strikes the anode will be V equal to root over 2 ev by m. So E is the charge on the electron, which is 1.6 into 10 power minus 19, into V is 1200 divided by m, which is 9.1 into 10 power minus 31. So this will be equal to, so which is approximately, we solve it, then we'll get 4.43 into 10 power 14. So its square root, if you do, that will be approximately 2.1 into 10 power 7 meter per second. So it means that option A is the correct answer. So hope all of you have understood the steps of the solution of every question. So if you are unable to understand any steps of the solutions in any of these 50 questions, then please write us in the comments section. And any other doubts if you have, then also please write us in the comments. And please install our Sapience education application, whose link has been provided, where we shall upload some important homework questions on previous year KCET exam also. So thank you everyone. Bye.